Hi everybody, welcome to week 5. This is a pretty typical week in terms of the deadline. So you have a quiz due Monday night and you have your standard daily checks and video notes due on Tuesday, Thursdays, and Sundays, and your lab due Wednesday. We are taking the quiz on Monday on Newton's second law, so modules 4A and 4B, and then we're going to dive into work and energy, ultimately getting to conservation of energy, which is another main law. But I'm going to spend this start of week video talking a little bit more about the impact of camera angle on our video analyses. Last week's video, I gave some good examples of what happens with the difference in calibration distance, being close or far to the camera. And so I wanted to try to come up with a good example of what a camera angle issue, whether it's perpendicular or not perpendicular to the motion, would be. So what I came up with is this, where what we're looking at is on PowerPoint, just a still picture of a brick wall in my house. I positioned the camera really well lined up and on the floor, aimed at this brick wall. And so if we zoom in down at the bottom, this is going to be where it's more perpendicular. So if I had motion here, it would be more perpendicular to the camera. And we can see I have these little boxes kind of pre-drawn, and we can see that when I line these boxes up with the bricks, that the boxes are all about similar sizes. So all these bricks are just about the same size in this area down here. So these are all similarly sized. And so then as we scroll out, you can see that it does appear to get smaller. That's our perspective as it moves up, right? And so if we had some fixed calibration distance, it wouldn't be correct as we move further up. And so as I look up here, I have these green boxes. Let's go ahead and size out some of these bricks up here, again kind of doing that same thing, seeing that there's some repeatability to all of these different bricks. And so what I'm going to do then is just take one of these green and from the high up part of the wall and one of these orange, and then let's zoom in and we can see a substantial difference in the horizontal and the vertical motion, position measurements of these bricks. And in fact, if I go to their dimensions, one of them is about 0.82, so inches wide, and one is about 0.71 inches wide. So this is going to be bigger than a 10% error, almost a 15% error in position measurements from nothing more than just the skew of the camera angle. So if I was going to drop a ball here and try to measure its position as a function of time, and again, pivot gives us a very evenly scaled scale. It doesn't allow for the change in camera angle. So pivot scale would skew these measurements and we would have up to a 15% error in the measurements from when the object is moving not perpendicular to the camera. And so we need to be able to account and acknowledge this systematic error. This isn't a mistake that we're making in our measurements. We can measure the height of this green square just fine. It's just that if we had motion there, it would appear that it was moving less than it actually was. So as something fell the length of one brick, we would measure that as a smaller amount than the true amount. And so all of the position measurements, horizontal and vertical, get skewed the further the angle is, the bigger the angle is with that camera. And so that's something that's going to show up in future labs, in our midterm projects, in our final projects, because we need to analyze these videos, but then also acknowledge that there might be some systematic error built into our measurements and try to interpret that. So hopefully this example gave us a little bit more idea as to what I mean by the impact of camera angle on our video analysis. Keep on keeping up. Everybody's doing a great job with that and participating in Discord, helping each other, having me check in when I see questions, and working ahead so that you have time to get those answers before the deadlines. And keep an eye out for Rob's office hours as well this week. Okay, good job, everybody.